Okay, guys, I'm going to start the session. So, hope you guys can hear me, right?
Yes.
Okay, great. Thank you. So, now I'm going to start the session. Today, I I'm planning to do this session like more focus on questions in mid-exam review, especially for chapter 3, because I think you may have like about 15 to 10 to 15 questions from chapter 3. So I'll more focus on questions based on chapter 3. Okay, so first let me share my screen. Okay, as you can see here, in the mid-exam review, chapter 3 questions start from number 16. Okay, so last time I did chapter 1 and 2. So especially this chapter 3 based on some numerical stuff. You have to calculate so many things. So first thing is find the mean. This is the first part in your chapter 3, and also you will be having a question to find mean, median, and mode from those three. Okay, so first one, find the median from the given sample data. So you have this given sample data. Okay, I'll move to chapter 3 and explain how you can find the mean. Okay, so from this mean, median, mode, you will be having a question. You will be having questions. Okay, this is how we find the median of a data set. Summation of the observation divided by number of observations. Okay, here numerator summation of the observation, which means summation of the values, summation of all the values, divide by number of observations, how many observations are there. Okay, we call that mean. uh, from this example, okay, I'll show you this example. How do you find the mean? So mean equals to summation of all the observations, which mean you have to add these values: 88 plus 75 plus 95 plus 100. Okay, then divide by number of observations. How many observations are there? 1 2 3 4. 4 observations. Okay, so when you simplify this, use your graphing calculator to solve this, you can find the mean. Okay, this is how we find the mean. It doesn't matter how many observations that you have in your data set, you have to follow this step. Okay, okay, then using the same procedure, you can find the mean in this data set. Okay, number 17, again find the mean. Okay, let's see number 17. Yes, find the mean. Here mean is go and round the nearest tenth. So they have mentioned that you have to find the mean, but round that value to the nearest tenth. Okay, which means first digit, first decimal. Okay, okay. When you round a number, please keep that in your mind. The number just right side of that particular number should be, if it is 5 or greater than 5, then left hand value is like adding a 1 number. Okay, so that's the formal procedure. I think you may know that how we round a number. Okay, okay, next one, find the median of the given sample data. Okay, find the median. This is the this is the way how we find the median of a data set. First of all, remember, please keep this in your mind. Arrange your data set in ascending order or increasing order. Okay, that's the number one. In median, it's like dividing. Divide your data set into two pieces. Okay, that's the idea behind the median. It divides your data set into two pieces, like 50-50. Okay, if you have odd number of observations, median is the exactly the middle number. If you have odd number of observations, if you have an even number of observations, then the median is the middle observation of the ordered list, which means you will see that later. It's the middle value of that particular values. Okay, you should remember this particular like formula to find the median. N plus 1 divide by 2. Okay, n mean number of observations, n denotes number of observations. Okay, n plus 1 divide by 2, it gives you the position, not the value, position, which belongs to the median in your data set. Okay, you have to first order your data set. Okay, let's check these two. These two. Okay, here you have odd observations, odd number of observations. I think 3, 6, 7. Now 7. N equals 7. Okay, n equal here. N equal 7. Sorry, it should be simple n. It doesn't matter which n you use. Now what you have to do, n plus 1 divided by 2, that's the position. First check that whether we have ordered list or not. Okay, this is not the ordered list, so if you order this, then it should be like okay, let me change this to an order list. 4, 7, then this should be 9. Yeah, okay, now this data set, it is ordered list. Okay, ascending ordered list, 9, 11, 9, 20. Okay, now you can find the position. So position equals n plus 1 divided by 2. Here n is 7 plus 1 divided by 2, which means 7 plus 1, 8, divided by 2 is 4. Okay, so fourth position. Now you can count 1, 2, 3, 4. Okay, position is this fourth position. What is the value? Is 9. So value in fourth position, is 9. So this is your answer. Okay, okay, things can be little difficult if you have even number of observations. Okay, you have to follow the same procedure. So so let me clean this. So okay, first again you have to make this list as an ordered list. Okay, 30, 32, 25. So first thing is to make an ordered list. Okay, 20, 25. 25. There are two 25s. then 27. Okay, now you have ordered list. So again, how many? N equals n equals 1 2 3 4 5 6. N equals 6. So you can find the position by n plus 1 whole thing divided by 2, which means 6 plus 1 divided by 2. 6 plus 1 is 7, divided by 2 is 3.5. So can we find a position like 3.5? No, there are no position like 3.5. So that you have to do find the value belongs to the third position and fourth position. Okay, so value in third position, I mentioned third position is 25. See, third position value 25. So 25 comma value in fourth position is 27. Then I need more space. Okay, then you can find the median by taking the mean of these two. Okay, which means simply 25 plus 27 divided by 2. Okay, it gives you 26. So 26 is the median value. Don't worry, 26, that value is not in this data set, but that's the median of this data set. Okay, that's how we find it. Okay, number 19, find the median. Okay, first check how many observations are there. Okay, 20, 20, okay, 21. 21 based on find the mode. Okay, find the mode. Actually, in a particular data set, there can be one mode or many modes. Okay, or no mode. Okay, that can be happen. That can be happen. So without any problem, we can find the mode. There are no calculations. You have to just go through the data set and find the mode. Mode is the most frequent value. Mode is the most frequent value. Okay, so if any data set, let's say we don't have a particular value that has that has not more than one occurrence, then there is no mode in that data set. Okay, if no value occurs more than once, then that data set has no mode. Otherwise, any value that occurs with the highest frequency is the mode. Okay, so do we have, yes, I have an example here. In this case, when you, it doesn't matter the data set is ordered or not, that's fine. You have to just go through the data set values and check the frequency. I can see 25 repeats twice, other values just once. Okay, so here mod is 25 because it has the highest frequency. Okay, okay. What else we have? 22, find the mode. Okay, same here, find the mode. It doesn't matter whether we have numerical or non-numerical, you can find the mode. Okay, most frequent observation in your data set. Okay, number 23 says find the sample standard deviation. Okay, standard deviation is one of the most important section in our syllabus. Before I go to the standard deviation stuff, Yes. If mean and median are, if they are same, if that values are same, then your data set, the distribution of your data set looks like this, the middle one, middle graph. Okay. If median is, let's say median is less than your mean, then that distribution of the data set is like this first graph, skewed one, right? Skewed. Okay. Otherwise, it's going to be like left skewed. Okay. Just get a rough idea about that shapes of these distributions. Okay. I think you may have seen this before. This notation we call sigma notation. We used to denote the summation. Instead of 1 plus 2 plus 3 plus 4 plus, we use this notation like sigma I equals 1 to whatever value n, xi or x, which mean summation from 1 to 1 up to n. 1 plus 2 plus 3 plus something something plus n. Okay, that's why we use this sigma notation. The below here I equals 1 mean I mean the variable, how this summation goes from 1. This is the starting value 1. On top of that, in here k mean the highest value, the maximum value you can reach. I is equals from I start from 1 to k. Here it's k, so 1 to k. Inside this sigma, we denote we mention our variable. Here it is xi. Xi mean x values, observation values. So I mean from 1 to k. I goes from 1 to k. So x1, x2, x3, x4 up to xk. Okay, in between they have sum, they have plasma. Okay, this right hand side shrink into one place, and you can write that using this left hand side notation. Okay, we use this notation from this point. Okay, so I cannot edit that. Here you have an example, so please check that example. Okay, before I go to the sample standard deviation, sample mean. Sample mean is exactly the same idea behind the mean. Okay, sample mean is the mean of this particular sample. Okay, summation of all the values divided by number of observations. Summation of all the values in your data set, in your sample data set, divide by number of observations. Okay, we denote it by x bar, this highlighted one, x bar, x on top of that bar. Okay, we call it x bar. So sum or summation of xi divided by n. N is the number of observations, or we call it sample size. Sample size means number of observation in your sample. Okay, then we can find the mean, same as the mean, summation of all these possible values, 81.6, 84.1 plus 87.6 plus 82.8 plus 82.0 divide by sample size, or how many observations, 5, divide by 5. You can find the mean x bar. Okay, variation. So this is the standard deviation come into play. Okay, there is another one you should know, range. It is very easy. Range mean maximum minus minimum, maximum value minus minimum value. So you can have that gap. Okay, width. Standard deviation. Standard deviation measures the variation of our data set. Variation, how we deviate from the midpoint, how your data set deviate from the midpoint. So to find the standard deviation, this is the formal expression to find the standard deviation. We denote the sample standard deviation by simple s. So square root of summation xi minus x bar square divided by n minus 1. Here n is the sample size, x bar mean the sample mean, xi mean particular observation, ith observation. I can be 1 to whatever value up to n. Okay, x1, x2, whatever. Okay, so you can use this notation, or you can use this not the notation, you can use this formula to find the standard deviation. Okay, please use your calculator. You don't need to do it by hand, just use your calculators. Okay, if you let me check. Okay, do I have a place? Right. Okay, so I'll try to explain it here. So S equals, okay, S equals, simple S equals square root of summation xi. Okay, this means how do I write the square root? Okay, okay, before that I'll write this one, xi minus x bar. Xi mean just that particular observation. Okay, x, let's say 1, minus x bar. X, how do I write bar? No, if I use it like this, it is useless. So let me get a text box here. Okay, now I can write it. S equals okay, S equals square root. Think now I can add the equations, square root. Yes, here you can find the square root. Summation of xi minus x bar. Summation mean plus. So this guy xi I'll denote by x1. Okay, x1 minus x bar. Yes, x bar, your mean, sample mean. Summation mean plus. So plus second observation. X1 mean the first observation, x2 is the second observation. So x2 minus x bar. Okay, so likewise you can go up to n. I don't know how many, just can go up to x n, nth observation minus bar. Okay, then divide it by divide it by okay, divide that by n minus 1, n minus 1. N n here it's like n minus 1. Okay, divide by n minus 1. Here you have just a single square root. Here I entered two separate square root. It doesn't matter. Okay, they are same. That's how we find the sample standard deviation. Use your calculators, find the sample standard deviation. Sometime I know that your graphing calculator has direct access to this kind of standard deviation. So please check the graphing calculator's manual or just Google it and find how to find the standard deviation by using your graphing calculator. Okay, so that you have to just enter these numbers, enter these data set values, and simply find the standard deviation. You don't have to use this kind of formula. Okay, okay. Next one is also find the sample standard deviation. Okay, range. I told you how to find range. Maximum value minus minimum value. Here maximum value is 17, minimum value is 4. Okay, so 17 minus 4 is 30. Okay. Again, find the range. 27, find the range. Okay, maximum minus minimum. Okay, there is a problem I have given in given by using your empirical rule. Okay, we have a theoretical part called empirical rule. It is a very popular rule in statistics. Just a moment, please. In this, in your notes, there are two separate formulas to find the standard deviation. So this one I already this one I already explained you this formula, and also there is another formula which has been derived from the previous one, from this one. So they are same. You can use whatever you want. Okay, this is the standard deviation and mean. Okay, let's check this empirical rule. Okay, this is the empirical rule. Okay, there are three properties in this empirical rule. For any data set, following properties hold. Approximately 68%, okay, from your observation lie within one standard deviation. What is one standard deviation mean? X bar is the mean. Okay, I'll show you the graph in next page. X bar plus or minus S. X bar mean the mean, sample mean. S is the simple S is the sample standard deviation. So X bar plus S or S bar minus S. Okay, so between these two area, between these 2 points, this says that approximately 68% of the observations lies inside this gap, inside this interval. Okay. Property 2 says approximately 95% observations lies between two standard deviation, which means X bar plus or minus 2 times S. Okay. Property 3 says approximately 99.7 observations lie within these 3 standard deviation, which means X bar plus or minus 3 times standard deviation. Okay, which means simply this picture. So this figure illustrate the empirical rule. Okay, see, X bar is the middle point. Here in black color you can see X bar, that's the midpoint. Then one standard deviation, which means X bar plus S or X bar minus S. So within this purple color range, okay, about 68% observation you can see here. Okay, so two standard deviation, X bar plus 2S, S X bar minus 2S. Within these red color lines, there are about 95% observations in here, same as the third one. Okay, about 99.7 observations are there. So you can use these percentage and these 1 standard deviation, 2 standard deviation, 3 standard deviation to find the particular percentage. Okay, so I'll show you how you, I think, yeah, I'll do this example. Okay, this is I already done in the notes, but here I'll also do this example using empirical rule. So if in any case you have to deal with empirical rule, then you should recognize, okay, we have to use 1 standard deviation, 2 standard deviation, or 3 standard deviation. That is tough. Okay, so here blood pressure of 18 years old woman, roughly bell shape. Okay, roughly bell shape distribution, which means it's normally distributed, normal stuff what we are talking in this section. Mean of this much, mean of this much, mean of 120, and standard deviation 12. Okay, mean, which mean x bar. Okay, let me, okay, x bar. X bar is how much? 120. And S means standard deviation is 12. Okay, standard deviation is 12. So what percentage of this woman have systolic blood pressure between 96 and 144? So what's the percentage? So you have to find this percentage using empirical rule. So first of all, you should identify these values, these given values lie between these values lie between which standard deviation? 1 standard deviation, 2 standard deviation, or 3 standard deviation. Okay, so you have to first check that one. You have these values x bar and s, so you can check x bar. Do you remember 1 standard deviation plus or minus s? Okay, so 120 plus 12, 120 plus 12, x bar plus, let me get a text box, then okay, x bar plus 12. So x bar plus s is how much? 120 plus 12, which means 32, 132, 130, 32. Okay, does this value 132 equals to 144 or 96? No. Okay, then you have to move to next standard deviation, 2 standard deviation, which means simply x bar. Okay, I'll copy this, x bar 2s, x bar plus 2 times s, 120 plus 2 times 12, which means 144. Okay, now you can see 144 is exactly same with this value, which means this is like within 2 standard deviation. But to make sure that, you have to check this value as well. Okay, you can check x bar minus 2s. which means 112 minus 2 times 12. 2 times 12 means 24, which means 96. Okay, yes. So this means where this is in between two standard deviation, x bar plus or minus 2 times s. Two standard deviation. What is the percentage in between two standard deviation? It is 95%. This red color, two standard deviation is 95%. So percentage is 95%. Clear? That's how we use the empirical rule to solve the problem. Okay, I think this is the last part, I guess. Okay, please try this question using empirical rule. Okay, this is very similar to that one. I think yes, you may have a question from an empirical rule as well in your mid exam. Okay, it's very similar to this question. What is the quartile or interquartile range Q3? Okay, you have to find what is the range. Okay, Q3. What is the range Q3 in this data set? There are a few things you should know. 5 number summary. There is a technique or a theory part we call 5 number summary, which mean including this interquartile or not quartiles, not interquartile, quartiles. Q1, Q2, Q3. That's how we define it. Q1, Q2, Q3, quartiles. Okay. Okay, let's check how we find this. First quartile we denote by Q1, second quartile we denote by Q2, and third quartile we denote by Q3. These quartiles, they divide your data set into pieces. For an example, Q2 is the median. Q2 equals to median. Q2 equals to median. But first quartile mean median, after the median, first half. If you find the if you can find the median or Q2 in that particular data set, as I mentioned before, that Q2 or median divides into a data set into two pieces, 50-50. Okay, first 50, which mean we call that bottom half. That bottom half of the data set again divided into two pieces by using this first quartile. Okay, next one, third quartile is the second 50%, which mean we call it top half. Okay, this third quartile divides that top half into two pieces. Okay, so that's how they define. So let's see how we find these quartiles. First one, arrange the data set into increasing order or ascending order. That you should remember. Okay, you should remember that first of all you have to create an increasing order data set, ordered data set. Next one, find the Q2. The easiest one is to find the Q2 median. Q2 equals to median of that particular data set. So you can find the Q2, which means the median, using the methods what we have used before, n plus 1 divided by 2, using that. Then you will be having two data sets divided by your median. Divided the ordered data set into two halves, okay, by using your median. Bottom half is the first part. Which one? The next part, top half. Top half is the second half. Okay. So next you can find the median of the bottom part, median of the bottom half, which means Q1. Again, we find the median of the top part, top half is the Q3. Okay. So let's check how we find this. Q2. Without any problem, you should be able to find the Q3. Okay. First of all, you have to check again whether this data set has odd or even observation. Okay, if it is odd number of observations, you can directly find your median n plus 1 divided by 2. Okay, n plus 1 divided by 2. Here you have 6, 9 data set, sorry, 9 observations. So 9 plus 1 is 10 divided by 2, 5. Fifth position is your median, 1, 2, 3, 4, 5. So your median is 20. Okay, I'm not going to repeat that calculation, just find the median of this data set. Then, okay, 20, this guy is the median. So this one, 20, divide into your data set, divide your data set into two pieces, two halves, this part and this part. Okay, so first part we call bottom half, this part we call top half. Okay, so you can find Q1 using this half, find the median in this half. Okay, so they have mentioned how do we find the median of those halves. If the number of observations is odd, include the median in both halves. So here your number of observations is odd. So you have to add your median Q2 in both halves to find Q1 and Q3. Okay. Okay, consider this half, including your median, including 20, find the Q1. Using this, find the median of this part. So what's the median? N plus 1 divided by 2. How many? What's the n? 1, 2, 3, 4, 5. N is 5 here. Okay. 5 plus 1 divided by 2, which means 6 divided by 2. It is 3. Third position. So simply you can find the third position. Okay. This is your Q1, which is 16. Okay. Next, get the top half including your median, including your Q2. Because why? Because you have odd number of observations. Okay, if you have odd number of observations, then you have to add your median Q2 to both halves, find Q1 and Q3. Using this again, n plus 1 divided by 2. What is n here? It is 5. 5 plus 1, 6 divided by 2, 3. So third position is starting from your median value, 1, 2, 3, which means 25. Okay, this is how we find Q1, Q2, and Q3. Okay, okay, let's check how we do if we have even number of observations. It doesn't matter. Okay, even number of observation or odd number of observation, same method you have to use to find the Q2 or median, n plus 1 divided by 2. Here I let's say 3, 6, 9, 10. You have 10 observations. So 10 plus 1 divided by 2 is the position. So position, it is 11, which means 5.5 position. Okay, so get those values from the position 5 and 6, add them together, divide by 2. Then you can find the median Q2. So fifth position here, 1, 2, 3, 4, 5. 5, 6, 8 plus 9 divided by 2, which means 8.5. Okay, this is your Q2. Now you can see here 8.5 is not in your data set, so it is not here. You cannot find that value. So again, that value, you know, it is in between somewhere these two. Okay, so it again in general divides in your data set, divides your data set into two halves, bottom half and top half. Now you can use your bottom half to find the Q1 and top half to find the Q3. Okay, now here if you have even number of observations, you don't have to add your median to find Q1 and Q3. Okay, simply get these values and find your median. Q1 using first half or bottom half, Q3 using top half. Okay, here Q1 is 5, Q3 is 12. Okay, and again n plus 1 divided by 2. Okay, that's how we deal with range, deals with Q1, Q2 and Q3. Okay, here you have to find Q3. So order this, type this data set into ordered list, then find it. Interquartile range. Okay, interquartile range means difference between difference between Q3 and Q1. Interquartile range, I think we have, yes, this interquartile range we denote IQR. Okay, IQR equal Q3 minus Q1, difference between Q3 and Q1. Just simply subtract Q3 Q1 from Q3. Okay, so find Q1 and Q3, subtract them, you can find the interquartile range. Okay, IQR. Phi summary. Okay, what is phi summary? Phi summary mean phi number summary, which mean your Q1, Q2, Q3 and mean max, minimum value, maximum value of that particular data set. Okay, those are the phi number summary. If any case you have to answer like phi number summary, find the phi number summary of this data set, question something like that, you have to find Q1, Q2, Q3 and minimum value, maximum value of that data set. Okay, so you should know first of all you have to find the ordered data set, okay, or data set into ascending order, then find these values. Okay, that's how we find the phi number summary. What is this box plot? Okay, please pay attention about this box plot. Okay, you will be having a question in this box plot as well. Okay, once you figure it out, Q1, Q2, Q3, min, max, those values, you can draw this box plot. Okay, so to draw this box plot, you should know what is Q1, Q2, Q3, minimum value, maximum value of that data set. So after that, you can draw this box plot. Okay, in this box plot, let me go to the box plot. Okay, I'll come to this part later. Box plot. Okay, see, determine the quartiles. Potential outliers. Okay, just forget about outliers for a moment. Draw horizontal axis on which number of obtains in step 1 and 2 can be located. Above the axis, mark your quartiles and connect them. Simply find Q1, Q2, Q3. These are the steps how you should draw this. See, this is the minimum value, maximum value, Q1, Q2, Q3. Then just using a simple rectangle, connect them. Okay? Simple lines, connect them. Okay, there is no line inside this box. Okay, there is no vertical, no horizontal line inside this box. Okay, please check that. See, there is no horizontal line. This axis do not go through this box. Okay, so first draw this box, then draw this horizontal line. Okay, okay, that's how we draw the box plot. But still there is something I should tell you. Okay, first do this question. So using this data set, find min, max, Q1, Q2, Q3 and draw your box plot. Okay, it doesn't matter these gaps, these white spaces, the size of the box, it doesn't matter. Only thing is you should mention these values correctly. Okay, that's the important thing. Doesn't matter the size of this box. Okay, so if you have a question like this, try to focus on values, q1, q2, q3 values, and draw this. Okay, so you have to find the best option from these four. Find the values and get the best choice from these four answers. Okay, please pay your attention for minimum value, maximum value, q1, q2, q3 values, all 5 values. Okay, all 5 values, because they are different. See, if you check this is 95, this is 99, so please check that as well. Okay, okay, there is one more thing. When you draw the box plot, here it is just the box plot. They haven't mentioned anything regarding to outliers. If they have mentioned draw the box plot and mention the outliers, then you have to follow this. Outliers mean observations which are outside from our observe area. Okay, which are outside from our observe area. Simply you can find the observation by using this lower limit and upper limits. Okay, lower limit mean q1 minus 1.5 times IQR, interquartile range value. Upper limit mean q3 plus 1.5 times interquartile range. So if you have any observation that beyond these two values, okay, greater than upper limit, less than lower limit. If you have any observations which are less than lower limit, greater than upper limit, then we consider them as outliers. Outliers we mention in the box plot by using a star. Okay, by using a star. Here you don't have to worry about the outliers because they haven't mentioned anything like that. Okay, just box plot. Last two questions based on population. So find the population mean of the data set. Population mean, population, still we talked about sample. Okay, but now they have mentioned something regarding population. Population, descriptive measures for population. When you go to the population case, idea behind the mean and standard deviation are same. Okay, but here it is population mean. Population mean, population standard deviation. Last time we discussed sample mean, sample standard deviation, but here population mean, population standard deviation. So how we find the population mean? Summation of all the observation divided by population size or number of observation in that population. Okay, here mean, population mean we denote by mu, Greek letter mu, and number of observation or population size we denote by capital N. Okay, that's the difference between these notations. Okay, so you can find this, you can use this formula to find the population mean, and use these one of these formulas to find the population standard deviation. See, population standard deviation we denote by simple sigma. Simple sigma, we call this sigma. Okay, not that sigma for the summation, simple sigma. Okay, okay, let's see what we have here. Find the population mean given data set. So summation xi divided by capital N, number of observations, you can find the mean. Again, here population is standard deviation. So use one of these equations or formulas to find the population standard deviation. So you will be having a population mean or population standard deviation kind of questions in your exam. Okay, so this is the total, I mean, whole summary or big picture about your mid exam. So please pay your attention to this mid-exam review, and also the exam review answer sheet which I sent you earlier, handwritten answer. So I have explained as much as I can in this handwritten answer sheet. So please go through that and try to make sure you are studying in these particular questions, this particular theoretical part. Okay, so this is the end of this review. If you have any question, you can ask, or you can simply email me just before the exam. Okay. Okay, then I think that's all for today. So thank you very much.